My name is Andy Schweitzer and welcome to a small video on balancing chemical reactions. This has been covered a couple times in class already or in previous science classes. So we're going to walk through a couple ways, but let's start with a simple example. Let's say, for example, the formation of water would be hydrogen. It is a diatomic molecule, so it's H2 plus O2 yields and H2 waters. Actually, it's going to be water, H2O. Now, one thing you should realize is that during a chemical reaction, we aren't gaining any hydrogens, we're not gaining any oxygens, we're not gaining any chemicals at all. All we're doing is rearranging atoms. We have a hydrogen molecule, we have an oxygen molecule, looks like this, and we're forming some water molecules like this. So in the process of the chemical reaction, we are breaking some bonds here. These are breaking, and we're forming some new bonds. So turns out that when we break these two bonds, we can build our water molecule and still have an oxygen left over. So that means we break another one of these guys to form to use up my last water molecule. So they're used in different proportions. In order to make our water molecule, we don't need as much oxygen as we need hydrogen. So we end up using more of this than we do of this. That kind of ends up coming out in the actual balancing process. In the balancing of a chemical formula like this, we have a couple things I'd mentioned. We have the numbers out front, and they would go right here. These are called coefficients. These are telling me how many of these individuals I have. Now, and I can, for example, if I would have two of these guys, H like this, I will take two hydrogens and one of these oxygens to form one water molecule, take two of these hydrogens and one of this oxygen to form another molecule of water. It's a matter of just putting together a little jigsaw puzzle. These two here, I'm going to change my color here, these two rearrange and form a water molecule, and these two go together to form a water molecule. And here's my two water molecules that I would produce. Just a rearrangement of atoms. Okay. Now, how do we actually get to that point from our coefficients? These little things here are called subscripts. These are subscripts. Those cannot be changed. That's telling me H2O, that I have two hydrogens and one oxygen to make my water molecule. This is what I want to make. I don't want to change the formulation of what I'm making because this is what I want to make. All right, so process for balancing. Again, it's a little bit more problem solving, so it can be a little more challenging. It's not a one-which way to do this. You need to be able to hunt and search and try different methods, but here's one way to try and keep you on track. All right, so I have H2 plus O2 yields H2O. All right, now step one I usually write down as being diatomics. Okay, now as far as diatomics mean, there are some elements that come in pairs. I'm going to flip to the next page here and briefly give you a little description of diatomics. There are two elements in each diatomic, hence the word di meaning two, and atoms mean atomics. So they are as follows: nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These all come in pairs in nature. We're not going to get one of them. It's like buy two, get two. It's a two-pack. And the other one is H2. This is sometimes referred to as the Super 7. There are 7 of them. This is actually how they form on the periodic table. They form the shape of a 7 on the periodic table. And of course we have hydrogen, which is not, it's more to the left on the periodic table. So Anytime you see one of these guys, if it says, nitrogen and it's by itself, you put a 2 on it. If there's an oxygen by itself, you put a 2 on it. But for example, here, we don't put a 2 here because that would change it from water to a new substance. It has to be by itself to be diatomic. This is water, majority of your body is water. This is hydrogen peroxide, which would be poisonous to drink. 2 different substances. Right? Now, in this one, I've already added my 2's for my subscripts. Okay. My next step is going to be what I refer to as an inventory. Now, as far as an inventory is concerned, we want to know exactly how many atoms we actually have. I list them below the arrows. So we have hydrogen atoms and we have oxygen atoms. Again, how many do we have? Well, I have 2 here. I have 2 here. And I want to get to here. I have 2 and I have 1. Again, that 2 applies to the hydrogen. The 1 here is deleted, but it's there. All right. Next step, step 3, would be to increase coefficients. Okay. A little key, just pick one of these guys and try and fix it. I would say a slight key you might want to use is leave single elements until end. Meaning that don't change a single individual if you don't have to right away, because you can change that whenever you want and it is not going to affect other elements per se. All right, so now here, what do I want to choose here? Well, this is already even, so I'm going to go with oxygen. And I'll then simply increase this guy from a 1, and there's a 1 there, to a 2. And I'm going to change my color here so it looks a little different. I'll go to a 2. And that affects both of these. 2 times 2 is 4. 2 times 1 is 2. Now, I fixed this by putting the 2 here, but I sort of messed up the hydrogens. So now I got to go back and chase this one back. So you pick one, fix it, and chase it back. And I need to upgrade this one from a 2 to a 4. So add 2 here. 2 times 2 is 4. And I'm now balanced. Everything here should be even. Okay. Let's try a couple more examples. Combustion reactions are typically the hardest. There are other types of reactions which we'll be balancing coming up in chemistry, and the more you learn about the chemistry, the more you realize what's happening behind the scenes, similar to like this scenario where we know we're just taking these 2 things and 2 hydrogens, there's my 2 hydrogens, 1 oxygen, and forming 2 water molecules. It's pretty straightforward once you think of it like that. The more you learn about the chemistry, the more you're going to find out that the balancing is very straightforward. Combustion, albeit, still tends to be difficult. Let's take methane. CH4 plus O2 yields carbon dioxide and water. Every single combustion reaction will take an organic substance or something that is going to be oxidized, usually organic. It will have oxygen, and it will produce carbon dioxide and water. This is a standard. You should know as we go through the initial chapters or on reactions that this is what we get. All right, let's balance this. Let's do I have a 2 here ready for my diatomic. After you deal with these diatomics long enough, you'll just automatically put them in. Or if you see one on a worksheet that's missing it, go ahead and put it in. All right, so I have carbon, I have hydrogen, and I have oxygen. I have 1 carbon on this side. I have 1 on this side. All right. 4 hydrogens there. I have 2 there. So I'm going to put 4, and I'll do 2. All right. I have 2 oxygens here. And I have 1, 2, 3 over here. I like to leave that last single element till the end. Okay. And I will say for combustion reactions, I always balance it: carbon, hydrogen, oxygen, and they're always the same. They always form the same products. This tends to be a very simple way to balance. So carbon's first, hydrogen second, and oxygen's third. So 1 carbon, 1 carbon. 4 hydrogens. I got 2 there, so I'm going to bump this from 1 to a 2. And that goes to a 4. 2 times 2 is 4. Now, let's do the oxygens. Chase the oxygens backwards, and hopefully I can put a number right here, which will balance it. 2 times 1 is 2. 2 times 2 is 4. So that 2 upped this guy to a 4. And now, simply being, I would just put a 2 here. 2 times 2 is 4. Let's try another example. Okay. Let's do a chemical very similar to this one. Let's do methanol. It's an alcohol, like that. Again, it's an organic compound. I'll burn it, and it'll form carbon dioxide and water. Carbon, hydrogen, oxygen, in that order. 1 carbon, 1 carbon, 3 plus 1 is 4 hydrogens, and I have 2 hydrogens over here, so very similar to the last setup. I have 2 plus 1 is 3 oxygens over here, and I have 2 plus 1, I have 3 over here. Okay, so let's start with carbons first. They are balanced, all right? 4 here for the hydrogens, I have 2 here. Put a 2 here, that bumps this to a 4. 2 times 1 is 2, plus 2 more is 4, so this bumps that to a 4. Now notice, these are off here. Now, I need to get 1 more oxygen over here. I only want to put, I'd like to be able to put it right here, okay? But in this case, I can't. If I put a 2 here, I'm over, okay? If you can't easily place a number here and get it to balance, maybe this is odd, this is even, vice versa, then what I would do is change the 1 to a 2. If 1 doesn't work here, 2 will, every single time, hands down. If 1 doesn't work, if the oxygen won't balance with a 1 here, place a 2 here, and it will balance every single time. Now, I place a 2 here. Let's see how this affected everything. It doubled everything. 2 times the 1, this goes to a 2. This now, put a 2 here, kicks that to a 2. 2 times 3 is 6, plus 2 more is 8. Again, I'm doubling everything. So I need to put a bump this from 2 times 2 is 4. I need 8 over here, which means this is going to convert to a 4. 2 times 4 is 8. All right, so 4 oxygens plus another 4 oxygens. This got bumped to 8. Again, I doubled everything. All right, so now I got to get 8 over here. I currently have 2 plus 1 is 3. All right, actually 2 plus 2 is 4. So these 2 are going to stay there. I don't want to touch this one. So I need 8 total. 2 of them are here. I need 6 more yet, which would be a 3. 2 times 3 is 6, plus 2 more is 8, and I am now balanced. Typical combustion reaction. That's about as hard as it gets. Another type of reaction that we could balance would be an oxidation type reaction, and these are much simpler, but let's say we have copper metal plus silver nitrate, AgNO3, and this is going to produce copper nitrate, and the copper's got 2 charge to it, so plus 2 minus 1, so that's why I wrote my formula like I did, and the silver is now all by itself. Okay, so let's start out with our inventory. I have copper, I have silver, Ag, and I have this family which is staying together. If the family stays together, I balance it together. It works very easy like that. If it breaks apart at all, you have to separate it. But if it stays together, keep it together. All right, so I have 1 nitrate here, I have 1 silver, and I have 1 copper. I have 1 copper, I have 2 nitrates, and I have 1 silver. Okay, everything is balanced except for this guy right here, so I'm going to have to double this coefficient. I can't change. It'd be cool if I could put a 2 here, just to double that, but I can't. This is the proportion they come in. Increases to a 2. That bumps this to a 2, this to a 2. Chase it back, put a 2 right here, and we are now balanced. It literally is that simple. Okay. One example which I would mention here would be a situation where we have, let's say this, copper plus AgNO3 3 yields copper nitrate plus my silver. If you went through the balancing process and just say you got this, 2, 4, 2, and 4, this would be a situation where it does appear to be balanced. But it's not the simplest ratio. And this will be marked wrong. So make sure when you're all done, look it over and say, can I reduce down my coefficients? Can I divide all my coefficients by the same number? So divide everything by 2 would be 1, 2, 1, and 2. So make sure you reduce your coefficients. That can happen sometimes if you're going through the balancing process and you just keep going and you miss something, then you can have a higher multiple occur where it still appears to be balanced. That's it. Thank you very much.